This video is the normal distribution part 2. So we are picking up with the slide that says, what if we want to know points that don't happen to be exactly 1, 2, or 3 standard deviations from the mean? So if you will recall, we were talking about the empirical rule, and we had completed a couple of examples involving the 68, 95, 99.7% rule that says that 68% of the data is within 1 standard deviation, approximately 95% of the data is within 2, and approximately 99.7% of the data is within 3 standard deviations of the mean. So what if we want to know about points that are not exactly 1, 2, and 3 standard deviations from the mean? So you will recall z-scores. We learned those in previous videos. Now the definition of a z-score is how many standard deviations a data point is above or below the mean. So if a number or a value is 1 standard deviation above the mean, it has a z-score of 1. If it's 2 standard deviations above the mean, it has a z-score of 2. If it's 3 standard deviations below the mean, it's a z-score of -3. But we can also have z-scores that aren't whole numbers. So if you have a z-score of 1.67, that means whatever value that represents, that is 1.67 standard deviations above the mean. So we're going to use z-scores to describe the probability that a randomly chosen data point falls into a certain range. And that brings us to the area under the normal curve. So you've seen the curve, we've looked at the curve. We're going to start talking about the area under the curve. And it represents multiple things, 2 specific things that we're going to be focusing on. The first thing is the proportion of data points between A and B. This goes back to the empirical rule. 68% of the data falls within 1 standard deviation of the mean. 68%, that's a proportion, just in percentage form. So this proportion 0.68% of the, or 0.68 has approximately, it's within 1 standard deviation of the mean. That was a proportion that I gave you. And what we found, that 68% of the data, that 0.68, that was the area under the curve between those 2 points. We just didn't realize that. It also represents the probability that a randomly chosen data point is within that range. So if I found 1 standard deviation above and below the mean, I believe it was for the car problem over here, I believe it was between 16,500 and 17,500 because the standard deviation was 500. So between 16,000, we had 68% of the data approximately was between, if you will recall, 16,500 and 17,500. That's 500 below the mean, 500 above the mean, because 500 was the standard deviation. So the area under the curve between 16,500 and 17,500, this area right here, remember that's 68% of the data according to the empirical rule. Well, that's the proportion of 0.68, or that's the area under the curve between those 2 points is 0.68. That means that if we were to choose an individual at random from the population, the probability that they are between 16,500 and 17,500 is 0.68. So area under the normal curve has 2 meanings: the proportion of data between those 2 points and the probability that a randomly chosen data point is within that range. So proportion and probability is what is represented by area under the normal curve. Now we have something called a standard normal curve. That's a special normal curve where the mean is 0 and the standard deviation is 1. So a special normal curve called the standard normal curve has a mean of 0 and a standard deviation of 1. And that means a z-score converts a non-standard normal distribution to a standard one. What that means is you could convert any normal curve to a standard normal curve by finding the z-score for each value. Now, we use what is called a Zee table to find the area under the given range. So what in the world does that mean? So if we had a standard normal curve, I could find the area to the left of a specific z-score. So if I wanted to find the area between, or to the left, so let's see, here's the normal curve, standard normal curve, rather, and the mean is 0. The standard deviation is 1. So let's say I have a z-score of negative 1.65. The area to the left I can find using this table. So what we would do is we would find negative 1.6 on the left here. So here it is right here. And I'm just going to highlight, that whole row right here, the negative 1.16. And then we'll do a blue for the other one. 5. You would find 0.05 at the top. And you would find the intersection, which looks like the intersection is right here. There's the intersection, 0.0495. So the area to the left of negative 1.65, the z-score, is 0.0495. And that's how you would find an area using the table. So if we look, for instance, to find the proportion to the left of negative 1.73, you go down to negative 1.7 and you go over to 0.03, which you can't see, but at the top this is 0.00, 0.01, 0.02, 0.03, and you get 0.0418 would be the area to the left of negative 1.7. So the table will only find the area to the left. Now that area to the left, again, it is an area under the normal curve. It represents the proportion of the population that are less than that number. It also represents that the probability that an individual chosen would be less than that number as well. So we can use the table to find the following probabilities. However, we're going to actually concentrate on a different way to find that, because we have calculators that will calculate this for us, so we're not as bound to a table such as this. So I'm going to skip ahead and I'm going to go to the calculator. We're going to go back to those we're going to go back to those two examples that I skipped after we talk about the calculator. Now, you can use your calculator to find the area under the normal curve. It can be the area to the left, such as the area we found in the table. It can be the area to the right, or it can be the area in between. That's the other nice thing about the calculator, is you are not limited to just finding the area under the left. Now, to do this, we use our calculator and we hit second vars. Second vars. Well, you have hit this before, and you looked for binom PDF and binom CDF back when we talked about probability binomial distributions, binomial probability distributions. So we're going to go to the same place, second vars, and we're going to choose number 2, which is normal CDF. You will notice that there is a normal PDF, but we will not be using normal PDF. We're only using normal CDF. So that is number 2. So you're going to hit second vars number 2. Now, some of you will have prompts, some of you will not. Either way, you're typing in the same numbers in this order. So you are going to enter first. You need to figure out what boundaries bound the area that you're looking for. So you need a lower boundary, that's the left boundary first, and then an upper boundary, that's the right boundary. Then you are going to put in the mean and the standard deviation. Now, if you have prompts, will ask you for the prompts such as here. If you don't, you are going to enter those same numbers, the lower boundary, the upper boundary, the mean, and the standard deviation, and separate them with commas. Okay, so you are going to do second vars. You're going to choose number 2. And for those without the prompts, it's going to come up like this. It'll say normal CDF. And what you are going to enter is the left boundary, LB. I'm putting LB for left boundary, the right boundary or the upper boundary, the mean, and the population standard deviation. Close your parentheses. Make sure you separate each of those numbers with a comma. That would be a good thing to go on your note card. Okay. If you have the prompts, you will put those same numbers in. You don't worry about the commas. You'll hit paste, and then it will look like the screens that people have that don't have the prompts, and then everybody will hit enter. And then the number it will give you a number between 0 and 1, and that number represents the area within those boundaries, which also represents the proportion of the population within those boundaries and the probability that an individual chosen would be within those boundaries. So that finds all three things all at the same time. The number you get will be less than 1, more than 0. Okay, if you get a number greater than 1, check to see if there's an E with it. Most likely there will be. And that means that it's a number in scientific notation, which you will need to convert to normal notation. Okay. So what we're going to do is we're going to end the video here. And we're going to pick up with, we've gone back to example 3, one of those examples that we skipped. We're going to pick up with the example 3, and I'm going to show you how to use the calculator. I'm going to actually pull the calculator up so that you can see what the buttons look like and where they're located. And we're going to find the area under the standard normal curve for the following example. And that's what we're going to do when we pick up with part 3.